Yeah, so as I was saying, the first question says that you are given a date in the format YYY and then date, and you have to convert that into binary. Okay, so for example, for 2080, you have to be outputting this value. Okay, for 2 the binary is 10, for 29 the binary is this. Okay, so it's very simple. You take the input, you split it using the delimiter of hyphen, and then you convert that into binary and then join back using the hyphens. Okay, anyone has any problem in this? Hello.
No. No.
Cool. So we will go to the second question. So second question anyone has done?
हाँ वो बाइनरी सर्च से होगा उसका.
Okay, so how did you solve using binary search? So before that, like, let's read the question once.
Okay.
So the question says that you are given a you are given a integer array which is start. Okay, and then it has numbers like 6, 0, 3, and then you have a element or an integer called d. Okay, so what does this mean? That you have to select a number from every interval. Okay, so what are the intervals? So let's see, it's 0 to 2, which is 0 of this, and 0 plus 2. Okay, then you have 3 to 5. 3 is the starting element, and 3 plus 5 is 3 plus 2 is the ending element. Then you have 6, 8. Okay, like 6 and 6 plus 2. So from these three intervals you have to select a number. Okay, so let's say I select 0 from here, I select 4 from here, I select 8 from here. Okay, so what's the difference between 0, 4 and 8? Okay, so this is the difference of 4, this has the difference of 4 again, and 0 and 8 has a difference of 8. So what's the minimum difference of any two elements in the array? It's 4, right? So you take any two elements, the difference will always be greater than equals to 4. Is the question clear? So now you have to maximize this minimum difference. Okay, you have to maximize the minimum difference. Okay, the question is clear, right? Sakshi, Raj, Ayush, Karthik, Deepak.
Yes.
Cool.
Yes.
So
Yes.
what we are going to find out here before anything else. So tell me one thing, that if I give you a value x, okay, so can you ensure that whether x is possible or not? Okay, so given the intervals and given a number x, can you say that whether the answer x is possible or not?
We can say that it is possible. मतलब, we
How?
can check. Like for example, I mean, if you're saying X is the answer, then we will search through those ranges and we can find that one.
How are you going to search through the ranges?
I mean, like if your giving answer is 4, that means that basically the difference between the low and the mid will be that part. So I mean, if you're giving us a,
So, no, let's do one thing. Let's say we don't have the ranges. Okay, so let's say we have only 0, 3, and 6. Okay, so how do you say that whether and let's say the ranges were same numbers. Okay, 0 from 0, 3 from 3, and 6 from 6. Okay, and we had to choose 0, 3, and 6. Okay, so now can you tell that whether a minimum difference of x is possible between the adjacent elements or not? Sakshi, Ayush, Deepak. Like if you are given an array of 0, 3, 6. Okay, so how do you find that whether a minimum difference of x is possible or not between the elements? come on, you just find the difference between the adjacent elements and check that whether the adjacent difference is greater than x or not, right? Hello.
Yes, yes.
Now let's say what happens if the right range increases, like from 0 it goes to 0.2, sorry, 0 to 2, then 3 to 5, and then 6 to 8. Okay, what changes? So let's say if I choose 0 here, I have the liberty of choosing from 3 to 5 here. Okay, so even if the difference here from 0 to 3 is less than x, I can extend the difference by a maximum of d. Okay, so what I will do, I will first find out the adjacent differences. Okay, so first I will find out the adjacent differences. So for here it will be 3 and 3, right? These are the adjacent differences. Okay, so I can add at max d to these elements. Okay, so for example, let's say instead of 3 I choose 4. Okay, so my difference has increased by 1. So initially my adjacent difference was 3 here. So instead of 3, if I select 4 in this range, so let's say I have selected 4 in this range, this adjacent difference has increased by 1, right? So it has come to 4. Okay, so when I am increasing the adjacent difference from 0 to 4, okay, so I am also decreasing the adjacent difference from 4 to the number I am choosing in the last range, right? This is clear or not? That if I am increasing the difference, that is the first adjacent difference, I am decreasing the second adjacent difference as well, right?
Hmm.
Sakshi, Ayush, Deepak, right?
हाँ.
So अगर मैं पहला डिफरेंस को कम कर रहा हूँ, सॉरी पहला डिफरेंस को ज़्यादा कर रहा हूँ, द सेकेंड डिफरेंस इज गेटिंग लेसर. ओके, एंड मैं पहले डिफरेंस को कितना तक बढ़ा सकता हूँ? हाउ मच कैन आई इंक्रीज द फर्स्ट डिफरेंस? बाय अ मैक्सिमम ऑफ डी, राइट? बिकॉज 3 to 5 का डिफरेंस 2 है, विच इज डी. So I can increase the first difference by a maximum of d. But if I increase the first difference by a maximum of d, the second difference or the second adjacent difference is decreased by d as well. Okay, right? So
Yeah.
one more thing, what is the maximum, what is the sum of the difference I can get? Okay, like if I sum the adjacent differences, what will be the sum? Okay, so it will be the sum of all the adjacent differences of the starting elements plus d, right? Because I have the option of extending the adjacent difference by a maximum of d. ठीक है, this is clear?
Yes.
So I have to distribute this d into the adjacent elements in such a manner that is the minimum value is greater than x. Okay, so for example here the d is 2. Okay, so I will distribute it by 1 and 1. So I will be adding 1 to the first difference and I will be adding 1 to the second difference, right? So I'll make both of them 4 and 4 so that my minimum value is 4, and I will check that whether the minimum value is greater than equals to x or not, right? Because I have the option of distributing d over the adjacent elements, sorry, over the differences of the array. Okay, because when you are extending, so for example here initially you had 0, 3 and 6. Okay, so initially your differences was 3 and 3. Okay, so now let's say if you choose 0, 3 and 8 here. Okay, so your last difference is getting extended by 2, which is d. So you have the option of extending the differences by a sum of d, because your range is getting extended by d. So your adjacent differences will also get extended by a sum of d. ठीक है, this is clear? Sakshi, Raj, Ayush.
Yes.
Deepak has given a thumbs up. Sakshi, Ayush. Karthik has joined today only. Ayush, did you get it?
Uh, no, Manish, actually, I'm not able to
Okay,
do.
let's make it simple. So let's say 3 6. Okay, this is the initial starting array, right?
Yes,
So let's say what is the adjacent difference? 3 and 3, right?
yes,
So now observe one thing. So let's say instead of 3 I can choose 5, right? Because the range is from 3 to 5.
yes,
So if I choose 0, 5 and 8, what will be my adjacent differences? It will be 5 and 3, right?
yes,
So now observe one thing. I have increased the first difference by 2. Why I have increased the first difference by 2? Because I have taken the last element in the range of the second interval, right? So this difference has increased, right?
yes,
And one more thing I did wrong here. Instead of 8, let's say I have chosen 6. Okay. So this was 0, 3 and 6 and this is 0, 5 and 6. Okay. So this is 5 and 1, right? So when I am shifting the middle element towards right. So my first difference is increasing, but my second difference is decreasing, right?
yes, yes,
Okay. So this is the first observation, that the sum of the adjacent elements will be fixed,
yes.
right?
Yeah, yeah, got it. Yeah,
Cool. So first observation is sum of adjacent differences is fixed. Okay. Now the second observation here is that what is the maximum sum of adjacent differences possible? Okay. So let's say I choose 0, uh, 5 and 8. Okay, this is possible to choose, right? So my difference will be 5 and 3, right? So my maximum sum possible is the sum of adjacent elements, which is 3 plus 3 plus d. Okay, why d? Why this is getting incremented by d? Because I can choose any one interval and choose the last element, so that my difference is increased by d, right? Ayush.
yes, Manish.
So I can choose. So what I have observed here is that, let's say the initial array has a adjacent difference of 3 and 3. Okay, but I have the option of extending the differences by a sum of d, because I can choose uh, the ranges, or I can shift. So let's say I have 0, 2, 3, 5 and 6 and 8. Okay, so instead of 3 I can choose 4. So I am extending the second, or I am extending the first difference by 1. Okay, but if I extend the first difference by 1, my second difference will be decreased by 1. Okay, so let's say if I choose 8. Okay, so my second difference is also incremented by 1, because instead of 6 I have chosen 8, so it's getting incremented by 2. But since I have also taken 4 in the second interval, so it will uh, be decremented by 1, that is 4 from 4 to 8. Okay, so it's also getting incremented by 1. So I can increment the distances by a total of d, because the ranges have a length of 2 or d. Okay, clear, Ayush?
Yeah, clear.
So simple thing. Now the algorithm is very simple. I will first find out the adjacent differences. So let's say 3, 3, and let's say there is 4, 5. Okay. So now I will check whether difference of x is possible or not. Whether a minimum difference of x is possible or not. And let's say d is 5. Okay. And let's say x I am checking for 4. Okay. Let's say d is 2. Okay. So I will check that whether the difference is greater than equals to 4 or not. The difference is not greater than 4, right? So I will be adding 1 here. Okay, so it will become 4, and what I am left with, d has come down to 1, because I have shifted the second range, or the element in the second range, by 1. Okay, so for example, if I had chosen 3 in the first place, so instead of 3 I will be choosing 4. Okay, Now I will check that whether the second difference is greater than 4 or not. It's again not, so I'll be adding 4 here, sorry, 1 here again, so it becomes 4. Okay, so for example I will be shifting the element in the second interval as well. Okay, so I'll be taking 8 instead of 6. Okay, so observe one more thing here. So when I am adding 1 here, this the element in the second interval gets pushed to the right by 1, so so the 3 becomes 4, and also 6 will become 7 here, because if 6 doesn't become 7, this difference will not be this difference will not remain as 3. Okay, so when you are pushing the element in the second interval, you will also have to push the element in the consecutive or the subsequent intervals as well. Okay, so now when I am pushing or adding 1 to the second difference as well, so that means one more shift will be there. So from 7 it will become 8. Okay, so that's how you take 0, 4 and 8. Okay, now you understand that why this plus or this additions cannot be greater than d, because you can't push a number in an interval by more than d. Okay, because you can't push more than 2 from 6. Okay, so the maximum sum you can add to the adjacent differences is d. Clear? So this becomes 4, 4, 4 and 5. So a minimum difference of 4 is possible. Okay, and we binary search on this x, that what's the largest number possible for which we can have the minimum difference. Okay, so it will be similar something to this. We have a function, let's say function x, where we check that whether x difference is possible or not. Okay, and then we binary search on this x. We start from 0. Our left limit will be let's say a very large number, or you can say that it will be the largest adjacent difference. Okay, and then we binary search on this x. We check that whether function x is true or not. If it is true, we check for a larger x, otherwise we check for a smaller x. Okay, are you clear now why this has to be d? This
Okay, clear.
Okay, because when you are shifting by 1, so every intervals after the second interval, it's getting pushed to the right. Okay, so let's say if you are adding plus 1 here and if you are also adding plus 1 here, so that means all the intervals from this 3 till this 5 is getting pushed by 2, because this one plus this one. Okay, so if it gets pushed by more than 2, that means it's getting out of the range, because our maximum range as allowed is 2. From 6 it can go up to 8 max, you can't go beyond that. Okay, anyone has any doubts on the second question? Sakshi, Raj, Deepak, Ayush, Karthik, if you have seen the question. Wasim.
No, not finished.
Cool. So let's see. We go to the second question. Third question. So it says that you have a array 1, 3, 1, 5. This is actually easier than the second question. It says that if you jump from I to j, okay, let's say if you jump from I to j, your score gets incremented by j minus I into nums I. Okay, so you have to find the maximum possible score. Okay, so what's the intuition behind this? So before I tell the intuition, tell me one thing. So let's say if I have all same numbers, let's say I have all A's. Okay, what would be the score for jumping from 0 till the last index, which is 5? Tell me what will be the score in any perspective. No matter what is the value of A, what will be my score?
5A.
Correct? So
Yeah.
now let's say I am taking, instead of A, I am taking 1. Okay, so let's say I have 1 instead of A. Okay, so now what will be my score? My score will be 5, right? Hello.
Yes. Yes.
Right. So now let's say instead of 1 I have a 2 here. Okay. Now what will be my score and how should I jump?
1 to 2 and then back to last one.
Why should I jump to 2? Why should I jump to this? Why not directly?
Uh, because um, 2 will be the larger number from 2 to 5 jump. So that will be, I mean, it will make the score larger.
So what was our score? Our score says that j minus I into num psi, right? So we need,
Yeah.
so when we are on our way from 0 to 5, we need to make sure that whenever we can increase our num psi, we should increase our num psi factor. Okay. So when we get an
Yeah.
opportunity at the second index to increase our num psi, we will increase our num psi. So from 0 to
Yes.
2, we will be using this 1 as num psi. So our score will be 2 into 1. But as soon as we get an opportunity to increase our num psi, we will be doing that. So from 5 to 2, we will be using the num psi as 2. So 3 into 2, which is 8. 3 plus 2, sorry, 3 into 2 plus 2 into 1. Okay. So the intuition is very simple. Whenever you see that I can increase my num psi, I will be increasing my num psi. So whenever you see that, let's say I'm standing at the index I, okay. So I will be iterating over the array from 0 to n minus 1, okay. So whenever I see, let's say my current num psi, so let's say I have a current value or the current nums I am using. So whenever I see that the current value, or let's say the current index has a greater value than the current nums I am using, I will be starting to use that value. Okay. So initially I was using 1 as my num psi. So whenever I come to 2 and I see that 2 is greater than the current value I am using, I will be starting to use 2. Okay. So now let's say instead of 1 there was 3 here. Okay. So I would have switched to 3 when I have reached here. Okay. Because whenever I am getting a chance to increase my num psi, I will be increasing my num psi. Because here if I multiply with the greater number, my answer will increase. Okay. So the algorithm is very simple. Your num psi will be nums 0 initially. So this will be your initial num psi. Whenever you see that you find a element greater than your current value, you will be updating that current value with that larger number. Okay. And you will be keep on adding the score to the final answer, that j minus I into the current num psi. And whenever you see a greater value, you will be updating that num psi. It's as simple as that. It's very greedy solution. Sakshi, Raj, Ayush, clear? Deepak, Karthik, Arnab.
Yes. Yes. Yes.
So this solution or this question was purely observation based. So the main observation that you had to make is that, like, let's say initially if you have all equal elements, how would have you calculated the answer? Then let's say if you have got a bigger answer or a better answer, how can you increase the num psi? Okay. So let's go to the last question. Last question is a bit tough. Okay. So it says that you have a chessboard and you have pawns in some places. Okay, so let's say you have pawns at some places. Okay, and you have a knight initially. Let's say this is your knight position. So let's say there are two players, Alice and then there is Bob. So Alice moves first, I think. Yeah, Alice moves first. So at one step or in one turn, they will choose the knight to capture a pawn. Okay, so out of these four pawns, they can choose any one to capture. Okay, so let's say they choose this pawn to capture. Okay, So they will capture this pawn and the knight will move to this place. Okay, and how will the score be updated? So the score will be updated the number of moves required from the current position of the knight to move to the selected pawn's position. Okay, so Alice is trying to maximize the score, Bob is trying to minimize the score. Okay, both of them are playing optimally. Okay, so you have to find what's the maximum score possible. Is the question clear? Hello.
Yes, yes.
So how can I solve this? So before that, before solving this question, let's solve a sub problem of this question. Okay, so let's say I tell you the position of the knight or the horse, whatever you call, and I tell you the position of the pawn to be captured. Okay, how do you find the number of moves required to capture this pawn? This is the first sub problem. Given the position of the knight, let's say the knight is as x and y, and the position of the pawn to be captured is a comma b. Okay, how do you find the number of moves required for the knight to move from xy to ab? And let's say the knight can move in a very standard way, that is 2.5 steps. Okay, so it can move to x plus 1, y plus 2 plus minus 2, or x plus minus 2, y plus minus 1. Okay, as we do in real life chess. Okay, so how do you find the number of steps required for the knight to capture the pawn given both of their indexes? Come on, this is a very standard question, guys.
Use DFS and calculate all the
dfs
ways
is
to.
dfs is not. Think
Um,
why dfs or bfs, and why dfs or bfs, means which one out of dfs and bfs. DFS is
Like
the wrong answer.
we need to like find the fastest way to capture. So
Correct.
into uh,
So basically, we will
for
be
the shortest way, DFS.
see when you are playing a chess, you want to have the shortest path, right? You don't want to like wander around. Okay. So
Yes, yes.
basically, there will be a graph from xy to this x plus minus 1, y plus minus 2. Okay, so there will be a graph. So the graph denotes that from this position the knight can move to this cell, or from this cell the knight can move to this cell in one move. Okay, so there will be a graph denoting the moves of the knight. Okay, so you need to select the starting index, which is x and y, and you need to find out in how many moves or in how many steps you can reach a comma b. This is clear using bfs. Correct? आयुष, राज, साक्षी, कार्तिक.
yes.
कार्तिक समझ में आ रहा है या क्वेश्चंस देखे नहीं हो?
Last three, ये नहीं आ रहा
Okay, cool. So now we will have a function. So I am telling you how you should break a big problem into smaller problems. So I don't need to care कि एक्स वाई से कैसे मैं ए टू बी पे पहुंचूंगा. ठीक है, सो आई विल हैव अ फंक्शन दैट विल टेक एक्स वाई a b and it will give me the number of moves. So let's say which is n. So I have this black box now. So now what's my concern? How do I capture all the pawns? Okay, so how do I capture all the pawns? So here we will be using dp. Okay, how we will be using dp? So let's say we will be using bit mask. Okay, so let's say there are 4 pawns as I told. So we will be using bit masking. So 0 0 0 0 0 0 0 1, and it will be going up to 1 1 1 1. Okay, so this means none of the pawns are captured. This means the last pawn has been captured, and this means all the pawns has been captured. So we need to find the answer for this state, which means all the pawns has been captured, right? Hello, Arnab. Uh,
Yes.
so we will be doing a recursive DP. Let's say our DP function is called capturing pawns. So we will be taking the bit mask, which our bit mask is this. Okay, we will be taking our current knight position. So let's say which is XY, and we will be also taking whose turn it is, Alice or Bob's. Okay, so let's say we can denote it by a flag. Okay, clear? So now how we will see. So in bit masking we will know for what pawns are captured, what pawns are not captured. For example, let's say if this is the state, we know the second and the fourth pawn hasn't been captured. So we will see that from XY to, let's say, the position of the second pawn, how many moves does it take. Okay, so let's say it takes p amount of moves. Okay, so we will be updating our answer dp bit mask is equal to, so let's say Alice is playing. Okay, this turn is being played by Alice, so Alice is trying to minimize the answer, so it will be minimum dp bit mask comma dp. We are now capturing the second, let's say we are trying to capture the second pawn. Okay, so bit mask 2 to the power 0 1 2 2 to the power 2. Okay, like we are trying to capture the second pawn plus p. Okay, and sorry, I did one thing. So to capture the second pawn, what we will do, we will call this function recursive function capturing pawns. We will be sending bit mask, and we will make this 0 1 because we are trying to capture this pawn, right? So it will, we will be sending 1 1 1 0. Okay, so 2 to the power 2. Our position will be this pawn's position. Okay, and we will change the turn. If it is Alice, we will be sending Bob. If it is Bob, we will be sending Alice. Okay, so we will be changing the flag every time, and we will be sending the position of the second pawn. So let's say if this is a comma b. Okay, so we will be sending a comma b. Okay, similarly we will check what will be our answer if we are trying to capture the fourth position. Okay, so instead of 2 we will be sending 4 here. Okay, 2 to the power 4. So basically how we will do, we will be iterating over the bit mask. So let's say if we have 1 0 1 0, we will be iterating over every bit. We will check which bits are not captured. We will try to capture those bits. So we will check that what will be our answer if we capture the second pawn now, and what will be our answer if we capture the fourth pawn now. So let's say if we capture the second pawn, our answer is p, and if we capture the last pawn, our answer is q, and Alice is playing. So we will check with which one out of the two, p and q, is minimum, and we will take that. If Bob is playing, we will check that with which one out of p and q is larger or maximum. We will take that. Okay, and we will update our answer in dp bitmask and returning that value. Okay, finally we will print the value of dp 1111, which is I think 15 if we convert into decimal. Okay, so this state will be our answer. Clear, Ayush, Sakshi, Raj, Deepak, Arnab? Hello.
Anish, one part I wanted to know, like
Hmm.
when you are, can you scroll up? Yeah, so here you are doing this DP bit mask,
Hmm.
and then again for the like capturing pawns function, you
Hmm.
are sending this bit marks and bit mask, and there is like you are doing XOR, right?
Yeah, so what this is making sure that, see, we have 1010, right? We are capturing the second pawn, so our bitmask should change to 1110, right? So I
Yes.
need to change this 0 to 1.
Okay.
So I am telling, so what we do in DP, we solve sub problems, right? So I'm telling capturing pawns that give me the answer for the state 1110 and Alice is playing from the knight position A comma B. So give me the answer for this state. I am telling capturing pawns because when I am capturing the second pawn from this state, my next state becomes this, right?
Yes.
So I'm telling that give me the answer for this so that I can calculate whether capturing the second pawn is beneficial or capturing the fourth pawn is beneficial. So I'll be calculating the condition or the state for capturing the second pawn, and I will also calculate whether it's beneficial to capture the last pawn. And which one is more optimal, I will take that and go forward. Got it?
Okay. Yeah, I understood.
Arnab, Sakshi, Raj.
Yeah.
Yes,
Cool,
understood.
then just try out the questions. I think the last question was really good, and second question was really good. Okay, and third question was pretty easy, third and first. So just try out the questions and absolve. I have always told absolving is a must. Okay, cool then. Have a great day, everyone. Bye.